Welcome, listeners, to episode 4 of Crypto Convos. In this two-part discussion, Quantum Exchange's chief strategist Vince Berk chats with Rohit Sethi, CEO of the security by design firm Security Compass. The discussion explores the changing software development landscape, how to build security into development from the start, and the role of encryption in DevSecOps. Enjoy part 1, and please return next month for part 2.
Welcome, everyone. This is Crypto Convos. My name is Vince Berk. I'm the chief strategist at Quantum Exchange. And today I have with me, and I'm very excited about this, Rohit Sethi from Security Compass. Now, Security Compass, first of all, welcome, Rohit.
Thank you, Vince. Appreciate it.
So the reason this is exciting to me is that you focus on DevSecOps, right? Which is an area that I've been a long advocate for many years about. Sort of, security needs to be part of the development life cycle, but not just the development life cycle. It's not just the developer that must be aware of it, but there's also an operational component to it, right? Like especially as we're getting into sort of SaaS software, where we're both providing security, to the end user that's connecting to our service, but also the operations, right? Like the data we collect on the end user, that must be kept secure. So this sort of discussion and the problems around that are relatively new in the industry. I'm so really hoping we could have sort of discussions about that today. So why don't we kick it off with you introducing what it is that Security Compass does and what your expertise is?
Sure, I appreciate that, Vince. So I am the CEO at Security Compass. Security Compass is an application security company. We have been around for a while. As Vince and I were just talking about, the company was started in 2004, began as a consultancy where we were helping people with doing things like penetration testing or ethical hacking, breaking into systems, but with a spin where we were focused specifically on application security or software. After a while, we noticed there was a need for developer training, and so we started to offer that as a service as well. If you fast forward a number of years, we had a bit of a pivot, and we realized that we were finding issues in these penetration tests, but that ultimately there was a problem in the way people were developing software, to your point, Vince, from a software development lifecycle perspective. And that if you could integrate security in from the beginning, that in fact, we could just not have these vulnerabilities that we were seeing over and over and over and over again. And that was the genesis of a couple of things for us. One, e-learning product that we continue to have today, which is taking that developer training and making it role-based, easy for people to consume. We partnered with ISC Squared to offer a designation for software developers so that you can have specific expertise in, for example, Java or general web app development, but also people like, the QA team and really having an industry recognized credential around security. So that was one of the things that we did. And then the other thing that we did is we launched our SaaS platform, SD Elements. And that is essentially a solution to what we call developer-centric threat modeling. So it's integrating security into the very beginning of the software development process, security by design, not just testing, which is where most of the industry is today, but doing so in a rapid, scalable way. And so we've been at that for a number of years now. We're a bit early to the market, but have a number of very large, successfully deployed customers using it on, probably at this stage, tens of thousands, if not hundreds of thousands of software products.
Yeah, so that's excellent. And you're interestingly talking about some areas that I've gone through sort of this migration myself, right? And I want to sort of end with a question on sort of what have you seen as the industry changed? Because, right, so I was the founder of a startup that was at the very early stages of SaaS software, right? And we're like, we need to provide this as a service to people, but we're still very much in a paradigm of, well, you build a release, then you compile the release, and that release is going to happen, right? Like, it's sort of, and that, I'm talking like more than a decade ago, and sort of we had to go through that, and all of that technology was being developed like as we were, transforming, right? And obviously, I've then gone through several other product organizations, also gone backwards, sort of in time, if you will. You, though, have seen that progression of the industry all the way from the starting point of training through sort of like what we see today, right? Which is effectively, a whole new way of developing and deploying software, continuously, deploying updates, what have you, right? Whenever there is change in an industry, there's problems that crop up that we didn't foresee, right? And that's really where my question is that, we're going through this, we see lots of microservices, we see developers changing sort of the way that they do business, right? How are they adapting? Where do you see the biggest problems crop up? And this can be from a security perspective, also from a management perspective, right? Like, there's just as much of that, right? Like, what's your view on that?
Yeah, I mean, there's been a lot of change over the last few years, right? If you think about it, there was, and then they're all related. There was a migration to cloud. You're not seeing as much on-premise software development anymore, software deployments, I should say, and that has enabled people to do a lot of things that they couldn't do before. But then specifically the idea of cloud native software and just layers of abstraction that makes life easier for developers. You mentioned microservices, and so some of the I guess the changes in things like containers and sort of deployment infrastructure, and for people being able to use the changes in infrastructure to change the way that they architect their software, right, and make it easier to maintain, to reuse the same code base in a lot of different ways. Like, there's just been so many changes across so many different areas, and this is just a piece of it all. And so what we have seen, I'll start from a security perspective, is it's difficult to keep up, right? I remember, I'll say, date myself here, but I remember doing a security course on Java, right? Like, teaching people about Java EE security. And it was all about the concept of a monolith, right? You have a presentation tier and an app tier. You have your web server and you have a database server. And so, like, what are the different security components of these things, right? But if you talk to sort of a modern application developer, the world doesn't look like that at all, right? There's just these widely distributed teams, and they're all working on relatively small pieces of code, and they're all kind of interacting with each other. The idea of DevOps has certainly changed a lot of things, right? You mentioned, you used to have the concept of releasing annually or quarterly as sort of like the default because of how complex it was. And of course, now we have seen a big migration, really people doubling down on things like continuous integration, continuous deployment technologies, right? And then thinking about how that enables them to operate differently. So, releasing software much more frequently. Well, the challenge we have is that most of these security best practices from an application security perspective probably emerged in the era of the monolith of large, web applications. And it's been hard to keep up with all of the changes that have happened in the software development world, right? So for example, when we used to do penetration testing, the idea is you'd have an annual pen test. You'd have a security team come in and they'd look for security issues, and then they'd come up with a set of vulnerabilities that they discovered. You'd have to fix them, and then we'd issue a report. And that was it. Like, wipe your hands clean. We'll come back next year.
Job done. Right.
But if you're deploying multiple times a day and you're changing that code base, right, the effectiveness of that annual pen test is diminishing in terms of how useful it is to the consumer of the pen test report, right? Like, you're showing me how secure it was in October and it's March, and who knows how much the application has changed since then. How do you know it's still secure? So there has been a lot of innovation in the area, but not everybody's always kept up with the innovation. So there's still companies that only do penetration tests from an application security perspective. They don't really do anything else. I would say largely, though, the best practice has shifted, right? So people have started to adapt things like code scanner, static analysis technologies, right, that look for vulnerabilities in your code. And, that's tied really nicely. Theoretically, that's tied really nicely to this concept of DevOps, continuous integration, continuous deployment. If in your pipeline of tests, you have the ability to also look for security issues and reject a change, kick it back to the developer and say, go fix it, right? You have a much faster, tighter feedback loop. You don't have these long cycles between somebody found a vulnerability and you have to go back and fix it for the next release, which is 4 months from now, right? That can be really fast. And so what we've seen is, a lot of attention on this particular area: security testing, static analysis, interactive application security testing, dynamic application security testing. They're all different flavors and ways to find security issues in code. Another thing that has certainly become much more in vogue recently is the concept of, open source security. So
right,
more and more of your code, tends to rely on open source libraries that are written not by the core set of developers. And so it's not really about, are you writing secure code, but rather the libraries that you're using, are they themselves secure? Are they being discovered vulnerabilities, and are you keeping them up to date? And that turns out to be another thorny set of problems, because just knowing what vulnerabilities you have and all of the layers of infrastructure of code that are underneath your running application is really challenging. And then updating them and upgrading them is no simple feat in many cases, right? It might be a very major project just to upgrade something like an application framework. And so that's become another big challenge. Not to mention things like, how hard is it to secure the containers themselves? The deployment side of things, the infrastructure. So it's just an exploding kind of complexity from a security perspective. But what I would say, is really interesting, Vince, is that a lot of people have a mental model that security is a thing that you test for, right? So if you go back to the genesis of like a penetration test, you write code and then you find a security vulnerability. And so often people, when they think about DevSecOps, it's how do you insert security into DevOps? And you tend to see people really focus on this concept of shift left testing. How can I find security vulnerabilities earlier and earlier? But it's really the wrong way to think, right? What we're saying is write code and then find a security issue in it. Now, there's a bunch of challenges with this. One challenge is you're not going to be able to find all the vulnerabilities, no matter what kind of code scanner you use, because there's things that are architectural in nature, design issues, business logic issues, not to mention some technical issues that a particular scanner just won't be able to find, right? But then there's the idea that, like, even when you do get the feedback that there was a vulnerability, they're not always easy to fix, right? And any defect in code could be a monumental amount of effort to go back and fix. What if it's like a core architectural issue that, had you known about the issue ahead of time, you would have built the system differently, right? And so that's gives rise a little bit to, I think there's a rising popularity now on secure by design, right? How do you get past this mental model that security is the thing you test for, and it's something you build for? When you're building with security in mind, and you know what you need to do to make it secure. And then that testing, which you still need to do, is really just to find a defect of some kind.
Yeah, so first of all, you just put so much material out there. We could spend an hour unpacking each and every sort of aspect of that. Right. So thank you. But let me sort of follow up on that, because one thing that I recall, and I've managed these processes for companies with like dozens of projects before. It's like, how do you even find vulnerabilities? And you're speaking of an open source supply chain, which is generally, there's generally some level of tracking that can be done. Imagine you're also using tons and tons of private components of companies that are maybe no longer in business or in the same core. These things are absolute management nightmares, right? And they're very, very hard to do. And it's like death by 1,000 cuts if you cannot somehow operationalize that, right? Yeah. Which is I think sort of what you're entirely saying. You're making a business out of this. Also, it goes hand in hand with this whole concept of what you discussed as the QA process, right? So we think of QA as like, build the product, hand off the monolith as you speak, give it to QA, and then what does QA do with it? Like very often, a lot of QA is, does it do what the developer or the product manager says it's supposed to do? But very few people look for, does it do anything else, right? Like, is it doing things that are unexpected? Is it, what are these, or does it even produce an answer that's correct, right? That's a whole entire thing that often QA doesn't properly test for. Yeah, it got us an answer in the designated time that we hope the database would answer the time in. Yeah, is it the right answer though, right? Like questions like that. Whereas, like, to move to CI/CD, right, is essentially, it's a way in which we've gone ahead and we've thought about, well, we modularized our software to a degree where it's no longer just software and libraries and I can independently maintain those libraries, but I built them into one big end product. No, we've changed the entire life cycle. We've taken that concept of modularization all the way up to the deployment, right, of the product, like the building, the deployment, which means individual parts can be individually tested. We can overlap that. And that's a major shift. And I think that like one thing, and tell me if I'm right or wrong, you have way more, I mean, I've only seen this boots on the ground level. You see this in a lot of your customers. So I'm interested to hear your perspective on this, right? The people that manage these processes, right? The chief engineer, the chief product officer, right? They tend to be people that grew up in an era of the monolith software. There was a database, there was the front end, there was maybe a UI if you're really advanced, right? Whereas the people that are thinking about CI/CD and building software today, they're way more agile in theirs, right? And that's hard to change sort of that mindset. How do you see that?
Yeah, I mean, it's a great question. I think ultimately it depends on what industry you're in, right? So if you're in the software industry and you have competitors that are moving that quickly and your leaders don't buy into it, it's just a matter of time before you're usurped by the competition, right? Because they're just going to be much more responsive. So you see that. You see changes in leadership because people have to align with the speed of business. I think once you get outside of people who build digital products, I'll say software, hardware that the software enabled. You think about things like industrial control systems and these sorts of things, medical devices, all of that stuff has, software on it. And you'll be surprised how many of them have really embraced things like DevSecOps, even though they have really long cycles for hardware. But I think it's when you get into, industries that are using software more for their sort of back end or like their infrastructure as opposed to the product that they sell to customers. And so they're a little more abstracted from, what is the business impact if you move quickly or slowly. So some companies, like I'll say in insurance, for example, right? You'll see some companies that have really embraced DevOps and DevSecOps and move quickly because they see it as a competitive advantage to be able to respond quickly and deliver better business capabilities, right? They see IT generally as a strategic differentiator. But then there are other insurance companies that might rely more on their customer service and their brand. And, maybe they don't want to make big investments into IT infrastructure and they're generally change resistant. And so when you have a generally change resistant company culture, right, the idea of like adopting changes where, let's face it, if you want to embrace DevSecOps or DevOps in general, you have to decentralize control a little bit. You can't have like a command and control sort of hierarchy, and that doesn't jive with a lot of company cultures. So I think those are the ones that are probably the slowest to adopt. But I think what we're seeing though, right, and like a lot of the data I think coming out of industry supports this, is that the benefits, the ROI of using more sort of lean processes is so high that it's just so many organizations that otherwise are very slow to embrace change have moved really quickly to try to adopt DevOps. But there has been, you'll see inside these organizations a lot of fighting, right? Like senior people who really aren't aligned with these concepts, with these principles, sort of pushing back and often being pushed out as a result.
Yeah, I know, that's expected, right? And you know what? The next level of innovation will come right along.
Yeah.
So